Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of second prep, we are going to solve questions of Egyptian Knowledge Bank Nagwa platform. Okay, we have different questions today on sound. Okay, let's start with Unit 2 and its items for April exam. Okay, question number 1 says that which of the following speeds is closest to typical speed of sound waves in air? Okay, we have here a different numbers and we want which one or which speed is clear or typical to the speed of sound in air. Okay, we have here 1300 meter per second, we have 3000 meter per second, 300 meter, 3 1000 meter per second, and the last 1 meter per second. Okay, we have the speed in air. Okay, so we have 300, it is the nearest one, as when the sound return comes and returns back, when we can calculate its speed, it take 340 meter per second in air, 340 meter per second to in air. So the nearest number here will be letter C, 300 meter per second. So the number of speed or the speed in air, it is the speed that we can calculate by the going and returning back of sound when coming in front of obstacles. We have here the speed 300 nearest to the 340 meter per second. It is the true number for us for the sound waves speed in air. Okay, let's go into question 2. Question 2 says that the diagram shows an object, a person's ear, that is a short distance away from the object, and air particles between the object and the ear. What is the name for that is outlined here by the dashed red box? Okay, we have here dashed box with the red color. Okay, we have the distance from the center of this wave and the center of the other wave behind. Okay, so we can take the distance from one wave center, from center of distance of one wave to the center of the other wave, so we can measure what we can call a wavelength of sound wave. Wavelength of sound wave, distance between centers of two successive compression, or distance of center of distance between two successive rarefaction. Okay, so we have here compression, we have the center of the wave. Okay, we have compression and center from one wave to the center of the other, so we can measure the wavelength of sound wave. Okay, let's go into question 3. Question 3 says that in which of the following diagrams would sound not be transmitted from the object to the ear if the object is started to oscillate? Okay, we said that sound is a electromagnetic wave or mechanical. So mechanical waves can travel through space or can travel in vacuum? No, all sound and all the mechanical waves need a medium to travel through. So sound can't travel in space or vacuum. We have here no air. If we have no air, we can't move, or no sound can be heard by the ear. So we have here the right answer will be letter A. Okay, this is the right answer here. Okay, let's go into question 4. Question 4 says that the diagram shows an object, person's ear, that is a short distance away from the object, and air particles away from the object and the air. Okay, so what is the name for what is outlined with the dashed box blue? Okay, we have here the distance in rarefaction and the other rarefaction, center of rarefaction, and distance from the behind rarefaction also. So we have here a wavelength also of a sound wave. So we have here two questions. One, when the distance from center of refraction and other one behind the refraction center of it, so we have wavelengths of sound wave. And another one, if we have the center of compression and the center of the compression behind it, or the one after it, so we have the in each one we have the wavelengths of sound wave. So we are going to question 6. Question 5 says that which of the following diagrams correctly shows the positions of the air particles between the object and a person. حلو. Okay, air where the object is oscillating and when it is not oscillating. Here we have air particles, and when air vibrates, when we have air particles here and air vibrates, when we have air particles, so they are regular or no motion or no disturbance in the medium of air. Okay, so we have here object without motion, so air particles here regular in motion. After making a vibration or sound, we have here the particles of medium making what? Making compressions and refraction. Okay, the medium, so the right answer will be letter A. Right answer will be letter A, as the particles after making vibration for the medium make compressions and refractions. Okay, so we are going to question 6. Question 6 says that the diagram shows an object, the person air a short distance away, and air particles between the object and the air. Okay, what is the name for that shown outlined by the dashed box blue? Okay, we have here, we can call what? We have here the compression or refraction. Okay, if we have distance or we have the medium with high density and high speed, or make a compression means high density and high speed or high velocity, so we can say we are going to talk about compression. If the mediums are away from each other, so we are going to say the medium with low density and low velocity, so we can say they are refraction. So here in the box blue we are going to talk about a rarefaction region. We are going to talk about rarefaction region. Okay, let's go into question 7. Question 7 says that this also diagram we want to get the outlined red box. Okay, we in the previous question we have the rarefaction, in this one we have the compression or the air particles of high density and high velocity, so we are going to talk about a compression region. Okay, let's go into question 8. Question 8 says that we have here the diagram shows the positions of air particles between the oscillating body or oscillating object and a person's ear. Okay, we have here object make a vibration and ear with the vibration of the air particles. Which of the following diagrams correctly shows the direction of the motion of the air particles in the sound waves as the sound waves moves from oscillating object to the ear? Okay, we have the motion from the object to the ear. We said that the sound waves are mechanical wave and they are longitudinal waves. It means that they are travels from the medium along the direction of wave propagation, or travels from the source of sound along the direction of wave propagation. So we have here the right answer will be letter A. Sound move from along the direction. Here we have it's perpendicular here, so it not belongs to sound wave. We have the other question, are sound waves longitudinal or transverse? As we say, we are talking about sound, so you are longitudinal waves. So sound waves are longitudinal, mechanical as this sound need a medium to travel through and can't travel through space, and also longitudinal, it travels or make disturbance along the direction of wave propagation or in the same direction of wave propagation. So we are going to question 9. Question 9 says that the diagram shows an object a person's ear a short distance away and air particles between the ear and object. Object starts to oscillate. Which of the following diagrams most correctly show the how the air particles move when the object starts to oscillate? Okay, we said that the object here, in case of static or no motion, the air particles regular, but here when make vibration, the medium particles make vibration. So what is the way we can express that the body make vibration? Okay, we said that the sound make compressions or sphericals of compressions and reflections. So we have, in areas we have high density and high speed, and in some areas or some regions we have low density and low speed. So we don't have a regular motion, so the right answer will be letter B. Some make a compressions and some make reflections till reaches the ear of the person that reaches the sound to it. Okay, let's go into question 10. Question 10 says that this diagram, person ear here, object from object to ear, we have blue and red boxes. Okay, we want to know in which color dashed box is the density of the air least. Least means that is a minimum or is a decrease in amount. Okay, we have here big number of particles of air, so they are density, or that density is most, and here we have a small number of particles of air, so we have here low density of air. So we can mention, we have here in the blue box, we have the least density for air. This is the end question of our group today. Thank you for joining. I hope you enjoy this part of questions. You can connect us with any way of communication with YouTube or Facebook, and we have different questions for Egyptian Knowledge Bank. I hope you understand, and I hope you enjoy this kind of questions. We are going to solve a lot of questions. Please wait and please connect us. I hope you enjoy. Good luck and goodbye.